Hi everyone and welcome to part 2 of our Tinkercad video. In the first part we took a look at how to create a Tinkercad account, and we learned how you can bring in an object to the workspace here or palette, and in this case here we brought in a small breadboard, and we talked about what a breadboard is and how it works. In this part of the tutorial we are going to learn how to connect a simple circuit. So in video 1 we looked at this circuit here. This has a DC battery. This could be a 1.5 volt battery, could be a 9 volt battery. We have some wire here connecting to what looks like a light bulb, and it is, and that is one type of resistor that you can have in an electric circuit. The resistor could be maybe an element in a toaster oven, but in this case here it's just an old school light bulb. So we've got a really simple circuit here, and what we're going to try to do is build this on a breadboard inside Tinkercad. So let's go back into Tinkercad, and what we're going to do is we're going to go underneath components and basic components. We're going to scroll down and we're going to find a 9 volt battery. Here it is here. I'm going to pull it in here like so, and what we're going to do is we are going to connect it to the power rails of our breadboard. To do that, simply you're going to move your mouse to the end here, and you can see this is the positive part of the battery, and we're going to connect it to the positive rail of the breadboard. To do that, I'm going to click and hold, and I'm going to drag it to this first hole. I could do it to any of these holes, doesn't matter. I'm going to connect it to this one here and click again to show it's made that connection. It defaults to a green color, but this is the positive terminal of the battery, which we typically connect with a red wire. So there. Now what I'm going to do is go to the negative terminal of the 9 volt battery, and I'm going to connect it with a wire to the negative power rail on the breadboard, and I'm going to click here again and there. And again, it defaults to a green wire. We're going to change that to a black. So typically positive connections from a DC battery are made with a red wire, and black are used for a negative terminal. So what we're going to do next is connect up our light bulb. Now, in order to find that, we need to go here and go into all components. And there's a whole bunch of components here. Don't worry if you don't know what these are. A lot of these we're not even going to look at, but down here you can see that we do have a light bulb. I'm going to click and drag, and I'm going to bring it in here. And I'm going to drop it here. And what I want to do is connect this light bulb up. Now to do it, what I'm going to do is I'm going to click on this object, and I'm going to rotate the light bulb. So I can go over here on the left and I can click rotate, and I can rotate it around. And that way I'm going to have access to these holes right here. In other words, where this light bulb sits. Now, the way that you connect a breadboard to power up various objects is we connect a wire from the positive power rail to one side of a light bulb. So if I click and drag and put a wire right here, that is from the positive terminal of this breadboard. And to do that, let's make that a red wire. And then I am going to connect from the negative terminal over to this side of the light bulb and click again to connect. And there. And again, let's put that as a black because that's from the negative terminal. So there, what I've done here is I've connected the 9 volt battery to the breadboard, and then from the positive power rail and the negative power rail I've connected wires to the light bulb. So now what should happen when I start the simulator is electricity should flow from the positive side of the battery if we're following what we call conventional current flow, which we'll talk about later. It will go into the light bulb through the resistor that is the element that produces light, and then back through the negative terminal and back into the battery. So if we've connected it right, then when I press the simulator, then the light should turn on. And it does. It works. This is a closed circuit. Electricity can flow. If I stop the simulator, and if I just click on this wire here, and I'm going to click on my delete on my keyboard to delete that wire, I'm just going to show you something here. If I simply draw a wire from here, and let's say I draw it to this point right here, and let's just make that red. Now I've changed the wiring of this circuit, and if I go to run the simulator, it has started. I can see that the simulator time has started, but my light bulb is not turning on. And the reason why is this is what we call an open circuit. Because I have not connected to this positive side of the power rail, electrons cannot flow through the resistor in the light bulb to make it turn on. This is what we call an open circuit. If I stop the simulator and I put in another connector wire from this point here, and I connect it to here, and let's make that red. Now I have a wire that connects from the positive terminal or positive power rail through this row in the breadboard, through this wire which comes into this row, and now it should be able to get into the light bulb back through the negative terminal of the battery, and current should flow. So if I start the simulator, there, it does work. Everything runs as expected. So there, in your second tutorial, we have created a simple circuit with a 9-volt battery and a light bulb and connected it together on a breadboard. Hopefully now you understand the difference between a closed circuit and an open circuit. And that's it for this tutorial. Take care. We'll talk to you soon.